Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Iqbal Aizat bin Masturi. My team and I from Section 6 from Group D, and the title of this experiment is to analyze of fluid flow characteristic, the effect of height, time, and density of by using siphon process. That's all from me. Okay, now we continue to the introduction part. First, we actually must understand what is the siphon process is. Siphon process or the siphon principle is the idea that fluid flow from the area of higher pressure to the area of lower pressure. A siphon works by creating a temporary vacuum in a pipe which is then filled with water due to the difference in a pressure between the two ends of the pipe. So in this experiment, we actually have three objectives, which is first, we to determine how height affects fluid velocity measuring transfer times. Second, we actually to assess how time interval uh, influence the volume transfer at a fixed height, which is 25 centimeter. And lastly, we actually to compare the behavior of water, oil, and detergent mixture, which is the different density of each liquid under the controlled condition. That's all from me. Thank you. Now we continue to the next introduction. In this experiment, we have two tests, which is test 1 and test 2. In the test 1, we analyze the effect of height on flow velocity, which is in this setup at height of a beaker, we fill the different density of fluid, which is water, oil, and the detergent mixture with water, and the lower of beaker is the volume is fixed, which is we find the time to reach 250 milliliter at each different height, which is 25 centimeter, 50 centimeter, and 75 centimeter. In this test one, we actually find the time to get 250 milliliter, and from that, we actually can find the velocity is calculated using a formula when the fully transfer, which is 250 milliliter. And we continue to the test 2, which is we study the different density have impact of the volume at the time setting, which is 5 second, 10 second, and 15 second. We assume and we set up the height of each beaker is 25 centimeter constant. From that from that we can find the volume transfer from each time, which is 5 second, 10 second, and 15 second, and we mark on the big other beaker at the lower part, and we get the volume to calculate the value of flow rate, which is Q, and we actually can get the velocity of each fluid flow. That's all from me. Thank you. Now we continue to the theory part. In this experiment, we use two formula, which is Q is equal to VA and Q is equal to V over T. We know that the diameter of the tube is 0.008 meter, and we can find the of area. So as the test one, actually we can find the value of Q, which is flow rate, is equal to V over T, which is V is constant, which is volume 0.0025, divide by time we get of each density and of each different height. So from the flow rate we get, we actually can get the value of velocity, which is V is equal to Q over A, which is Q we get from the data before, and the A is area can get from the formula pi d square over 4. Same as the test 2, firstly we find Q is equal to Vt and V is equal to V is equal to Q over A. That's all from me. Thank you.
Use the suitable beaker for this experiment. Prepare the three types of fluid, which is detergent, oil and water. For the test one, set up the beaker at height 25 cm, fill with the detergent solution. Flow the fluid from the beaker using the tube and start the stopwatch. Repeat the experiment using different height 50 cm and 75 cm from the beaker. Repeat all steps using different fluid, oil and water. Record the time taken for each type of fluid and height. Just to set up the beaker with its height 25 cm from the second beaker. Flow the fluid detergent from the beaker to another beaker using tube for 5 seconds. After 5 seconds, record the volume the transfer fluid in the second beaker. Repeat the experiment using different fluids, water and oil at different periods, 10 seconds and 5 seconds. Record of reading to the table.
Okay, for the observation, in experiment 1, the relation between fluid height, viscosity, and flow rate was examined. The results show an increase in height decreased the flow time for all fluid due to the greater potential energy imparted by gravity. Among the tested fluid, water has a faster flow rate because of its low viscosity, while the oil was the slowest due to the high viscosity. The detergent water mixture exhibited an intermediate flow rate. Viscosity acted as resistant to flow with a minimal resistance for water, maximum resistance for oil, and moderate resistance for the detergent water mixture. Okay, this experiment demonstrate the highest fluid height reduce flow time more significantly for low viscosity fluid, as a gravity has a stronger effect in overcoming resistance. Okay, for the experiment 2, the focus was on the volume of liquid transfer through a siphon at a fixed height, different of 20 cm over varying time interval. Water has a highest transfer volume due to its low viscosity and minimal resistance of flow. Oil transfer has moderate volume as the highest viscosity created. And I think that's all for observation. Next to the next presenter.
So I will explain about the result. So for the test one, we will transfer 500 liquid millimeter to another beaker until it reaches 250 milliliter. We will using different type of fluid, which is water, oil, and mixture of detergent and water. And we will measure with different height from beaker 1 to beaker 2, which is 0.25 meter, 0.5 meter, and 0.75 meter. So for water, we will get 5.14 second, 4.74 second, and 3.27 second respectively to the height. So for the oil, we will get 77 second, 66 second, and 37.16 second. And lastly, for the mixture of detergent and water, we will get 12.56 second, 10.44 second, and lastly 7.48 second. So in experiment 2 or test 2, we will measure how much volume will be collected within 15 seconds of the three type of fluid, which is water, oil, and mixture of detergent water. So for the water, we will get 425 milliliter, and for oil we will get 110 milliliter, and finally for the mixture we will get 310 milliliter. So from that we will calculate the flow rate and the velocity of the fluid flow.
Discussion. Comprehensive overview for test 1. This test evaluates the duration required for three different liquids, water, oil, and detergent water blend to descend from various heights 25 meter, 50 meter, and 75 meter. This graph illustrates three separate lines, each corresponding to one of the liquids. First one is oil. Oil demonstrates the longest flow time at all heights, for example 77 seconds at 25, 66 seconds at 50, and 37.16 at 75. The extended duration is due to oil's higher viscosity, which generates increased resistance to flow. Although the time decreases with greater height, the reduction is less significant compared to water, as the viscous resistance limits the impact of gravity. Water consistently exhibits the shortest flow time across all heights. For instance, 5.14 at 25, 4.74 at 50, 3.27 at 75. This rapid flow is attributed to water's low viscosity, which results in minimal internal friction during movement. As the height increases, the gravitational potential energy also rises, further reducing the time required for water to flow. Next one is detergent water mixture. The detergent water mixture shows a middle ground behavior. For example, 12.56 seconds at 25, 10.44 at 50, 7.48 at 75. The addition of detergent slightly raises the viscosity of water, resulting in a slower flow than pure water but faster than oil. The consistent decrease is time with height suggests that the detergent influences the viscosity not as significant as the oil. Comprehensive overview for test 2. This evaluates the total volume of liquid collected over specific time intervals of 5, 10, and 15 seconds. The graph features three distinct lines, each corresponding to a different liquid. First one, water. Water demonstrates the highest cumulative volume across all intervals, recording 0.000115 meter cube at 5 seconds and 0.000225 meter cube at 10 seconds and 0.00031 meter cube at 15 seconds. This swift accumulation can be attributed to its low viscosity and high flow rate, which facilitate rapid filling of the collection container. Next one is oil. Oil exhibits the lowest volume accumulation at each time interval, with measurement of 0.000065 meter cube at 5 seconds, 0.0009 meter cube at 10 seconds, and 0.0011 at 15 seconds. This outcome is primarily due to its high viscosity, which impedes flow and restricts the movement. Next is detergent water mixture. The detergent water mixture presents a moderate accumulation pattern with volume of 0.0001 meter cube at 5 seconds and 0.0016 meter cube at 10 seconds and 0.00025 meter cube at 15 seconds. The introduction of detergent slightly increases flow resistance compared to pure water, resulting in reduced volume collected, although it is still surpasses the volume accumulated by oil. General observation. The results clearly show that the time taken for liquid flow decreases as the height increases. This relationship is consistent across all three liquids, demonstrating the role of gravitational potential energy in enhancing the flow rate. Each liquid exhibits distinct flow behavior influenced by its density and viscosity. Water flows the fastest to its low viscosity, while oil flows the slowest, indicating high viscosity. The detergent water mixture flows in the intermediate between the two. Next one is effect of height. For all three liquids, increasing the siphon height 0.25 to 0.75 meters, significantly reduces the flow time. This can be attributed due to greater gravitational energy imparted to the liquid at higher heights, resulting in an increased driving force for flow. For instance, water flow time decreases from 5.14 seconds at 0.25 meters to 3.27 seconds at 0.75 meters. Oil showed a similar trend with a larger time span, which is 77 seconds at 0.25 meters and 37.16 seconds at 0.75 meters. Highlight its resistance to flow. The detergent water mixture demonstrates an intermediate reduction in time. The impact of density and viscosity. The flow of behavior of the liquids is influenced by their density and viscosity. First one is water. With the lowest viscosity, it flows easily through the siphon, making it the least resistant to flow. Oil, due to its high viscosity and lower fluidity, oil experiences significant resistance to flow, resulting in longer times. Detergent water mixture. The addition of detergent slightly increases the viscosity of water, reducing its flow rate compared to pure water but maintaining lower resistance than oil. So next one, dynamic viscosity analysis. The dynamic viscosity values derived from the flow time and density align with expectations. Longer flow times correspond to higher viscosity. Oil significantly higher viscosity is consistent with its slow movement, while water rapid flow corresponds to its low viscosity, while detergent mixture occupies the middle ground for both two of water and oil. Conclusion: this study successfully carried out an analysis of the effects of height time and fluid properties on the flow of characteristics of water, oil, and detergent water mixture in siphon process. Key findings are as follows. Impact of viscosity. Low viscosity water signifies that fastest flow rates and highest volumes transferred. That means minimal internal resistance to flow. High viscosity, which is oil, indicates much lower flow due to increased internal friction. Role of density. The driving force was the force of gravity that pulled the fluid through the siphon. Although density may play a part in this, it was probably only secondary. The effect of density is not important. Thicker liquids like oil, for example, do not flow faster because their viscosity cancels out the effect of density. Next one is time-volume relationship. The volume transfer increased linearly with time, aligning with theoretical siphon principles. However, deviations between theoretical and experimental values occurred due to factors like surface tension, wall adhesion, and minor measurement inaccuracies. So for recommendation, number 1, precision in measurement. Automated flow meters or high-speed cameras can be employed to reduce human error in recording the volume collected and time intervals. Maintain the constant diameter of the siphon tube throughout the study to remove the influence of changes in cross-sectional area on the recorded flow rate. Number 2, control external factors. Minimize environmental factors such as air pressure variations or changes in temperature, as they could influence fluid properties such as viscosity and density. Ensure the siphon is correctly primed, which is no air bubble present, to maintain flow consistency. Number 3, surface tension analysis. Conduct additional tests on detergent water mixture to analyze the effect of surfactants on flow rate and velocity. Using a tension meter to measure surface tension could provide better insights into how this property affects siphon efficiency.